Okay guys, this section we're talking about the normal distribution. So the normal distribution, if we look at this, it's the question, the mean of a normally distributed test score. So if something's normally distributed, it means that the numbers that we're looking at, the data, is spread out pretty evenly, that we can make this thing called a bell curve. So when we talk about the bell curve, we're going to talk about standard deviation. So for this example, the mean is 79 and the standard deviation is 4. If there are 184 test scores in the data sample, how many of them are in the 79 to 87 range? So here's a bell curve, and this 0, this is the mean. And then the 1, 2, 3, -1, -2, -3, these are all standard deviations away from the mean. So one standard deviation away from the mean has 34% of the data. 2 standard deviations away from the mean has 13.5%. And that goes positive and negative. So when you're doing these problems, it really helps to draw the bell curve. I've copied it just so I can write on it. So if the mean, that's the average, remember back to stats, is 79, that's the middle here. So this line represents the mean. And then standard deviation, this is something we learn about in middle school and then we revisit in 9th grade. But it tells us how variable some data is, how spread out it is. So if the standard deviation is 4, that means one standard deviation away, we would add 4. So 79 plus 4, this line would represent 83. And we would keep going. I would add 4 to get to the second line of standard deviation, which is 87. And then you would also go backwards. So this way, since the standard deviation is 4, we would take 79 minus 4. So this line would represent 75. Minus 4, this line would represent 71. So these numbers that I wrote down here, these are test scores. So the question is asking how many tests were in the 79 to 87 range. So I'm looking from here, 79 to 87 to here. So how many test scores fall in this part of the bell curve? All right, so that's 34% and 13.5%, so we're going to add those. 34 plus 13.5 is 47.5. So 47.5%, that's how much is in this area. That's what the question's asking for. So 47.5% of how many test scores? 184 test scores. So this is what we're trying to figure out. So I'm going to go to Desmos and I'll show you an easy way to do percentage. If I type 47.5%, Desmos inserts the of and then 184. So we used to, you can still, if you want to take 47.5% the old way, you would move the decimal back twice and do 184 times 0.475. That works too. So 184 times 0.475, you're going to get the same answer. So 87.4. What we're talking about people. We're talking about people that took a test. So I'm going to round down to 87. Alright, so this next one, again, I've just copied the bell curve into every question. you should draw it or have one you can write on. So the mean, that's the average of a normally distributed test score, is 82. So the mean is 82. That represents the middle. And again, we're talking about test scores. But now the standard deviation is 2. That tells us how many to move between each standard deviation. So I'm going to add 2. That's what the standard deviation is. So this line represents 84. I'm going to add 2. This line represents 86. And then you would go backwards this way. So here I would minus 2. This line would represent 80. And this would represent 78. So I just labeled it. Let's see what it's asking. If there are 235 test scores in the data sample, how many of them were in the 82 to 84 range? Well, right here is where we're going from 82 to 84. So 34% are in the 82 to 84 range, but we have 235 test scores, so we want to take 34% of 235. And I am going to use Desmos where I don't even have to convert. 34% of 235 is 79.9, and this time I'm going to round up, so my answer is 80. Face space is a popular form of social media. Recent reports show that the mean time, you want to look for this keyword, the mean. That's this middle part. It's the average. So the mean time is 45. I'm going to label that. This is 45 minutes a day with a standard deviation of 10 minutes a day. And the standard deviation tells me the difference. So if this is 45, this will be 55. You add 10 because the standard deviation is 10. This will be 65, and then I subtract. So this will be minus 10 at 35, minus 10 again at 25. So if 2,100 people are sitting or on in one sitting, how many of them lie within 2 standard deviations below the mean? So I'm going to start there. Here's the mean. 2 standard deviations below would be here's 1 and here's 2. So this chunk, and 3 standard deviations above the mean. So 1, 2, 3, all the way out here. So we are looking at 13.5% right here, 34%, 34%, 13.5%, and 2.5%. We're looking at all of that. It's asking how many percent is this? Well, guess what? These all add up to 100. So I'm just going to take 100 minus this lonely 2.5% that's left over. Or you could add all these up. But either way, you're going to get 97.5%. So all of this data is 97.5%. And we're looking at 2,100 people. So 97.5% of 2,100. 97.5%, and the of just pops up 2,100. 2047.5, because that's a 0.5, I'm going to round up to 2048, because we're talking about people. We're not going to have a decimal. The average battery life of 2,700 manufactured cell phones is recorded, let's cut off, and normally distributed. So the mean, that's our keyword, is 13 hours. So I'm going to go to the mean and I'm going to label it at 13 with a standard deviation of 0.5. So the standard deviation, remember, that's how I move. So I'm going to add 0.5 here. So this would be 13.5. This would be 14. And this would be 14.5. And then this would go backwards. 12.5, 12, 11.5. All right, let's see what we're looking for though. Find the number of phones who have a battery life in the 13.5 to 14.5 range. So I really didn't have to label all of it. I'm just looking here from 13.5 to 14.5. Okay, so I'm gonna add these. I'm taking 13.5% and 2.5%, which when I add those becomes 16%. So I want 16% of how many I have, and we have 2,700. So now it's just calculate. 16% of 2,700 is 432. So that's what you would type in. 432 phones are in that range. All right, Professor Fernandez is grading the final exam. He notices that the mean keyword is 68. So I'm gonna label that, that's my middle number. And the standard deviation is 8. That's how much I move in between my standard deviations. So if this is 68, this would be 68 plus 8, which is 76. And then I could keep adding 8 or subtracting 8 to get my other values. But let's see what the question's actually asking. If there are 450 students in the data sample, how many would have a test score between 68 and 76? Oh, so just this section. So that's 34%. And then I need to look at my total. My total is 450 students. So 34% of 450 is 153. So that's what you would type in. 153. Okay, a calculus exam that was taken by 118 students is recorded and normally distributed. So this is our total. The mean score is 74, so that's the middle. And the standard deviation is 2.4. What percent of the scores are in the 69.2 to 78.8 range? So I need to move around a little. I need to add 2.4 right here, which would be 76.4. And then I would add 2.4 again, which would be that 78.8. So that's my bottom. Now I need to go the other way to get to 69.2. So I would subtract 2.4 from 74. So 74 minus 2.4, and then I would keep going to get my values. So 71.6, and then this one would be my 69.2. So my range here is from here all the way to here. So everything except the 2.5 and the 2.5. So you can add all of these up, but remember all 6 of these add to 100. So I'm going to take 100 minus the 2.5s that are here, which is 95. And that's it. It's asking us to find the percent of scores in that range. So this range is 95%. It's not asking how many actual students on this one. So make sure you